In this video, we're going to learn how to calculate molecular formula. It's on the same page. You're going to glue this into your notebook, page 102. So here is the empirical one we worked on, and here's the inside. Okay. We're going to finish it. I'm going to turn it this way. And again, if I write it, you're going to write it. The molecular formula abbreviation is MF, and the molecular formula definition is that it shows the number and kind of atoms in a chemical formula. This is what you've been working with. You've only ever had molecular formulas. Right, here is the molecular formula, C6H12O6. It's showing the numbers and the kinds of atoms in the formula. Sometimes a molecular formula and an empirical will be the same, and a lot of times it will not. Right? So that should be on the outside. So you have the definition. There is the definition for you. Now moving on to the inside, because this example asked us to determine the empirical, we did that. We determined the empirical formula, and now we're going to determine the molecular formula, and I'm going to go through a set of steps on this side to do that. Right, so just as a review, the automobile antifreeze is composed of 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. The molar mass of this compound is 62.1 grams per mole. We haven't used that part yet. We need to determine the empirical formula, so we did that here. Here's the empirical. And now we're going to determine the molecular. The first step in doing that is to calculate the molar mass of the empirical formula. So we can totally do that. So we have our little formula here. I have carbons, hydrogens, and oxygens. I have 1, I have 3, I have 1. The atomic mass of carbon is 12.01. The atomic mass of hydrogen is 1.008, and the atomic mass of oxygen is 1599. I can do these ones just like that. I think it's 2, 4. I'll double check. Last step is to add. $31,024. We just did step 1. We calculated the molar mass of the empirical formula. Step number 2, we're going to divide the molar mass of the compound by the molar mass of the empirical formula. So we're going to divide given molar mass of the compound by the molar mass of the empirical formula. Right? So we take the molar mass of the given problem, right? We're going to take the whole molar mass and divide it by the molar mass of the empirical formula. Right? So here in this problem it says the molar mass of this compound is 62.1. So 62.1 grams per mole I'm going to divide it by the molar mass of the empirical formula, 31.024. I have that right there. For this particular step, when I'm done, I'm going to round again to a whole number. So even if I get a little bit of a decimal, 62.1 divided by 31.024, I get, I don't know if you can read this. It's probably easier on my phone. This is what my calculator gives me. So I'm going to round to 2. I'm going to round to 2. So many colors. Sorry about that. All right. Step 4, last step. We're going to multiply the whole number through the empirical formula. So this number 2. So we're going to take the 2 and we're going to multiply it through the empirical formula, through CH3O. So this is a 1 understood, so that means now there's 2 carbons. 2 times 3 is 6, and 2 times 1 is 2. And this is the molecular formula. So we started with percent. We started with a percent, which is something that a chemist could get in a lab. Okay? You could do some lab work and get those percents. And we determine both the empirical and molecular formulas.